Ever tried finding a title in a 400-page book without an index? Exhausting, right? Now imagine you are scrolling through contacts in your phone. Will you scroll one by one or just type the name instead? That's the magic of searching. Searching basically is finding an element, and today we will dive deep into two powerful techniques of searching: linear search and binary search. If we say searching, searching is everywhere. From your Google queries to finding that one pair of matching socks in your drawer. So, how do computers do it efficiently? Let's start simply. Imagine you have an array and our goal is to find an element, let's say 20. Simple enough, but how do we approach it? Here's our first method: linear search. So, linear search basically what it's do. It starts from the first element and compare and check it to the next element until a target element is found. So, starting at first, we will then move to the second element and so on. So here we will start from 30, which is present at our 0 index. Since 30 is not equals to 20, we will move to the next edge. Same 70. 70 is also not equal to 20, then 80, and similarly 60. Then next element is 20, which is our target element. So it is found. 20 is found at 5th index. Let's do coding part of it. So first, we will define a function. Let's say we define function linear search with two parameters array and x. Here x means the target element that we are searching for. Next, what we will do, we will run a loop to go through each element of the array. And if the element is present in the array, then it will return the element. Here what we have done that if the element is present at array, we will return -1. Otherwise, we will return 1. Otherwise, we will return -1. Now, let's take an example of an array. Imagine you have this array of 5 elements and you have to find the element 1. So, let's find this element, if it's present in this array or not. We are using simple if else statement to print if the element is present or not. Since you can see the element is present, so what will it print? It will print element present. See, the output is element present. It's simple, right? But here's the downside. Imagine you have a long list of numbers. And linear search is inefficient for large data sets. What if I told you here's a catch and faster way? Binary search. Its binary search is like a smarter detective. It starts by splitting the problem in half. Let's say our sorted list is this, and we are looking for an element, imagine 16. So, how does binary search approach? We will first find the middle element, and if the middle element equals to the target element, then it will return it. But if the middle element is not equal to the target element and it's greater than the target element, then we will do the search on left side. And if the target element is bigger than middle element, we will do the search on right side. We will continue this approach until we find our element. So here 23 is our mid element, 5 is low, let's say it's low, that is equals to 0 because our array starts from 0, and this is high, and high will be array length minus 1. Imagine why, as we start from 0, that's why we will do array length minus 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 minus 1, it's 8. So now we have to find 16. So 16 is greater than mid or less than mid. So 16 is less than our middle element. So we will do our search on left side. So now our array is this. Sorry. So now our array is this. We will now again check for the mid element. It's 12. Then we will see 16 is greater or smaller. Then 16 is greater than 12. Then we will again Then we will check that our low element is 16. That's how we do searching in binary search. Let's see code about this. So first we will define a function. Let's say binary search. And we will give two parameters array and x. Now low will be 0 as array starts from the 0, and high will be, as I told you, length of the array minus 1. So we will run a while loop, or if high is greater than or equal to low, then we will find our mid formula of our middle element. If middle element equals to our target value, then it will simply return the element. We will run if else to find our element. So if the middle element is a target element, it will return the middle element only. Or elif, if our middle element is greater than target element, we will do high equals to mid minus 1. Else, if our target element is greater than middle element, we will do low equals to mid plus 1. Now let's take a sample array and we have to find an element x in it. If answer equals to minus 1, that means the element is not present. And if it's not equals to minus 1, that means the element is present. So now let's run this code. But before that, I have done a mistake here. Can you find what is it? So the mistake that I have done is binary search works for large array and sorted array. And this is not a sorted array. Since it's not that big array, it will work efficiently. But if it's a big array with large numbers, then it will not work efficiently. So now let's run this program. Imagine you have to find element 100. Wait a sec. Imagine you have to find an element 112. So element is present. Element present. This 4 is the index. So 1 is at 0 index, 4th is at 1 index, 5th is on 2nd, similarly 7th is on 3rd, and 112 is on 4th index. So to conclude, when should we use linear search? Anytime you are working with unsorted or small array, and binary search for sorted and large array. Talking about time complexity, the time complexity of linear search is big often, and the time complexity of binary search is big O of log n. And the notes for the similar will be provided in the description with proper definitions, time complexity, difference, and algorithm steps with code. Thank you very much.